So today we're going to be talking about rates of change from a graph. Now I know that you guys have done this in middle school, but I want to again make sure that everyone's on the same page. So when you look at this, you are going to be given a graph and then you're going to have to create the rate of, or find the rate of change. Now, if the table works best for you, if you've been using the table and it helps you the most, then use the table. You're just going to have to pick some points from the graph and put them in the table. So if you look, this first point is at 0, 1. So time 0, distance 1. The next one is at 2, 4. And then the last point is at 4, 7. Okay, but I'm going to do from the graph first. So if you look, remember we talk about it has to be the change of the dependent, so the dependent by the change of the independent. So it went 1, 2, 3 over 1, 2. So its distance changed from 1 to 4, from 1 to 4, and then the time changed from 0 to 2. So this went up by 3, this went up by 2. Went up by 3 units and over 2 units. Okay, check the next point. It doesn't matter, since it's a constant rate of change, it doesn't matter which points you pick. Again, went up 3 over 2. So when you do this, I know that you probably had a teacher that said something like rise over run. This is a dumb reminder that I guess you could call it a dumb reminder. The way I remember it is wise over run. So instead of calling it rise over run, you call it wise. It's the y-axis over the x-axis. The change of the y's, change of y divided by change of x. Okay, so this is the way I remember it. Y's over run. Okay, so then our rate of change here would be 3 divided by 2, 3 feet per 2 seconds. Well, I don't want to know how much it's changing per 2 seconds. I want to know how much it's changing per second. So you would divide 3 divided by 2, and it's 1.5. So it's 1.5 feet per second. Okay? Then it's the same thing here, 3 divided by 2. So that is our rate of change. So again, I don't care which way you do it, but it will save you a lot of time if you don't have to keep writing out the tables. Okay? Yeah. Okay, here's the next one. Guys, if you should be graphing these in your notes. Sorry, I got really close to the mic. You should be graphing these in your notes. So if you want to borrow the graph stamp, I have one in my classroom, use it. Put the grid on your paper or in your notes and then graph this. Okay, so notice the first point is at 0 to 100. The second point's at 4, 150. Next point is at 8, 100. And then it keeps going. So you can use the table if you want, but I'm not going to in this one. Now this is where I always see the mistakes. So this one is going down. It's going down 2 units. But is it really going down 2 units or is it going down 50 units? Sorry, I have to erase that. So it's going down, it went from 200 to 150. So it actually went down 50 units. And I know it went down because it went from 200 to 150. And then it's going over 1, 2, 3, 4. So yes, it shows it's going down 2 units, but remember, each line is worth 25 whatever's, 25 feet. So it would actually be negative 50 divided by 4. So negative 50 divided by 4, negative 50 divided by 4 is negative 12.5. So that is your rate of change. And again, we'll check it again because it's a constant rate. It should be the same thing. So it went from 150 to 100, so it went down 50, and then it's going over 1, 2, 3, 4. So that would be the same thing. So it's going down negative 12.5. I know it's a negative rate because it's going down. The way I remember it is I always draw a little skateboarder, and I'm not an artist, so it's not the best. But if he moves from left to right, he would be moving down the hill or down the line, so I know it's a negative rate of change. Okay?